Hello everyone, and welcome to today's SANS webcast, Secure DevOps, 3 Keys for Success. My name is Carol Off of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Frank Kim. He leads the Management and Software Security curricula for SANS. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Frank.
All right, thanks so much, Carol. Hello, everybody. Good morning, good afternoon, good evening, wherever you might be. Before we dive into the webcast itself, I just want to mention that this webcast, Secure DevOps, 3 Keys for Success, is part of the ongoing SANS Application Security webcast series that is associated with this brand new course, DEV540, Secure DevOps and Cloud Application Security that we have. We'll mention a little bit more about this particular course at the end of the session today. Now, that being said, I did want to go ahead and mention that this webcast in particular is part of a 5-part webcast series, of which this is the first part of the webcast. So every month from now all the way up till March of next year, you're going to be hearing a little bit about Secure DevOps and different topic in cloud application security, as you can see here. So we are definitely excited about this epic 5-part series. So feel free to go ahead and go online and register, sign up for these webcasts today. Now, with all that out of the way, let's go ahead and do a very brief introduction here. As Carol mentioned, my name is Frank Kim. I've got my own security consulting and CISO advisory practice. Before that, I was the CISO here at the SANS Institute, currently lead the Management and Application Security curriculum, and have been the author and instructor for a number of courses, as you see down here at the bottom of the slide, over the years. And so with that as introduction, let's go ahead and dive right into the material. And I want to start with just a little bit of a story here. You know, I was having a beer with a friend a couple months ago, and he's been in security for a long time. And about halfway through his drink, he stops and he says, you know, Frank, I realize I finally understand why I don't like DevOps. And he says, well, DevOps is actually just another excuse for developers to have root access in production. Right? And this is a very common way of thinking here, right? So of course I proceeded to give him a little bit of a hard time. But the reason that I mentioned this is because this is directly related to DevOps here, is you've got this concept of walls of confusion, right? You've got the development team on one side of the house, the operations team on the other side of the house, and the key thing to keep in mind here is that these two groups, these two departments, these two areas of the company have different incentives. The development team, of course, wants change. They get incented to release new features to production on a regular, quick, frequent basis. Whereas the operations team on the other side of this wall of confusion, well, they have a different incentive. They want stability. And well, where is security in this diagram? You can see security is not even in the conversation a lot of times. And so if we take the approach of security, the traditional approach of security saying, no, you can't do certain things, well, we might not even be included in this conversation, further generating these additional walls of confusion. And so in this particular webcast today, I would like to share 3 different things that I've seen over the years that might help us in our organizations in terms of implementing, working with, and implementing secure DevOps for our organizations. And the first of these 3 is champion change. How do we go about creating change for our organizations and dealing with the change, both the business change and the technological change that our organizations are facing every single day? Now, Charles Darwin said, it's not the strongest that survive, it's not the most intelligent that survive, it's the ones that are most adaptable to change. So as we in security continue to figure out how to work with other parts of the organization, whether they be development, operations, other parts of the organization, various business units, well, one of the things that is a fact in this technology world, in IT and in security, is that technology changes all the time. Technology changes at a very rapid pace. And here on the screen, here on the slide, you can see that we've got your typical multi-tiered application architecture. You might have, right, a front-end load balancer in the middle tier, right? You might have your web server on the front end. You might have your application server in the middle tier here, and you might have your data tier, your database tier on the back end. And over the course of a number of years, many decades, right, we in security have figured out, well, what security controls, as we see down here at the bottom, do we need to implement? Our best practices to implement at these various tiers, whether they start on the left-hand side here in terms of firewalls, web application firewalls, authentication, access control, input validation, and various other security controls in terms of encryption at rest and securing access to our data. But now, right, as technology changes, well, we've got different architectures that have sprung up. We now, in a DevOps world, in a modern development world, we now have more and more of a microservice-based architecture. And so instead of your monolithic middle tier and your monolithic back-end data tier, you've got different services, whether they be the employee service you see here in the middle, the HR service, the account management service, and so on. And we have on the left-hand side a wider array of clients, a wider array of types of applications that could be consuming the various services, the various data that our organization has. Whether it be a single-page application, keep that one in mind in the upper left-hand corner. We're going to come back to that in a little bit here later on in this presentation. You can have various mobile applications, and now, right, you might even have various connected devices, the Internet of Things, your refrigerator, your toaster, right? Various other devices in your organization or even in your home might be talking to some of these microservices. And instead of your typical nice flow from the client applications all the way back through your multi-tiered architecture, now we have something a little bit like this. And consider, what does this do to the attack surface in a modern architecture? Now you've got a lot more interdependencies, a lot more connections. Your threat model, your attack surface has drastically changed in this particular architecture here. And so we need to figure out, well, what could we do? What do we need to do to, one, understand how DevOps is working, how development, design, system development, and deployment has changed in this modern world of DevOps and cloud security, but also, what do we need to do from a security perspective to better secure these modern architectures? And so let's take a look at a simpler version of this diagram here. And we've introduced a couple components. Here, towards the left-hand side, we have introduced an API gateway. And the API gateway, of course, right, is a broker, a single choke point that you can then now, well, direct some of this traffic a little bit more effectively. And, well, it's a nice choke point to embed some additional security controls into it as well. But there's something else. There's something else in this diagram. Right above the API gateway, we also, of course, have this little blue box for authorization, access control, and so on. And that little blue box, of course, represents, well, Lambda. Lambda functions here, something that's called function as a service. So not only is our overall architecture changing, microservices are being introduced, the way that services are exposed and consumed is different, but now under the covers we have some changing technologies here with the introduction of serverless computing. Now serverless, as the concept might have been around for a little bit of time, right? But the main benefit, the big change in serverless is that now we as application developers, we as system developers, we don't have dedicated servers anymore. We don't have dedicated containers, even Docker containers. Anytime you want to create a new bit of functionality, right, you've got a new serverless Lambda function in AWS, right? So this is sometimes also called function as a service. Anytime you have one of those particular events, like processing an HR request, like processing a request for a discount coupon like we saw on the previous slide, well, that event is going to trigger this new serverless function in this ephemeral environment. And there are a number of different cloud providers that are now providing serverless computing function as a service. AWS, of course, has Lambda, Microsoft has Azure Functions, and Google, of course, has Cloud Functions. But it's important to keep in mind that Amazon API Gateway, right, that API Gateway that we saw on the previous slide, is also, in and of itself, an example of a serverless computing function, right? Because we don't have to manage the server itself. We don't have to worry about standing up the server, installing our software, and so on. We just focus on the application functionality itself, the functionality of that particular function. And so what does this mean to us from a security perspective? As the technology environment changes around us, well, what do we need to think about to more effectively secure and work in this serverless environment? Well, the good news is that the attack surface is actually smaller, because now we've got no servers to patch, right? One of the biggest challenges that we have from a security perspective is effective vulnerability management, effective patch management. But if we no longer have servers to patch, because that is handled largely by our cloud provider, and we no longer have long-running servers that attackers can scan, attack, potentially install malware on them, we then therefore have fewer compromised servers. Because, right, conceptually, every new request to your serverless function as a service brings up a new clean environment, brings up a new clean server. Well, if that is actually the case, does that mean we don't have to worry about security anymore? Well, of course it doesn't, right? Now, it just paradoxically, using serverless computing, using these functions as a service, well, it makes the attack surface smaller, but as my friend and colleague Jim Bird says, it paradoxically makes the attack surface bigger at the same time. It's just that the attack surface itself has shifted a little bit. Now, potentially anyone with the right level of access to your cloud infrastructure, to your cloud management plane, can deploy a function. And they're incented to actually deploy these functions because the cost to deploy a new function is effectively zero. Unlike in the old architecture, where you'd have to stand up multiple servers, make sure that they were redundant and fault tolerant, you had to pay for that uptime of those servers. Now, unless your function is being utilized, you only get charged in your functions for when they're actually called and consuming resources. And so the attack surface perhaps becomes a little bit bigger because it's harder to track and manage and delete those particular functions. And this leads to another question about authentication and access control. Who should have permission to actually create and deploy functions in your environment? How do you lock down, how do you control the access of what each function can do? And importantly, from a compliance perspective, well, if this is serverless computing, there's no server that you're necessarily managing, how do you know what sensitive data is handled, where it's actually stored? Are there any multi-tenancy risks? And even from that overall compliance perspective, if you're using AWS Lambda, for example, right, well, you might want to make sure that your Lambda in your particular region supports PCI compliance, HIPAA compliance, and so on. So a number of security concerns, security things that we have to worry about from a serverless perspective. And now, as we said, paradoxically, the attack surface gets smaller, but then the attack surface also paradoxically gets bigger. The attack surface gets smaller from your traditional perspective. Now attackers can't as easily install malware on your long-running servers. If an attacker gets access to your traditional environment, well, one of the things that all attackers probably want to do is they want to maintain persistence. So they want to maintain command and control, some backdoor access into your environment. But if that's harder to do from an infrastructure perspective, well, of course then, the focus of these attackers is naturally going to shift from the infrastructure to the application. And I would say in this modern world of DevOps, in this world of cloud application security is even more important with serverless, right? Because every function itself, as we're thinking about each of these services or each of these functions, serverless components, that crosses a trust boundary. Not too long ago, I was doing an assessment, a test of a particular application, and I discovered, well, there was the front-end web application, and there are, of course, the back-end services, right? And these were two different teams that had created and maintained these two particular parts of the system. Well, it turns out that there was a lot of good input validation, sanitization on the front-end web application. But the back-end service, the back-end microservice, really didn't have any validation associated with it, built into its code. So, of course, we went to the service team and we said, hey, you should probably be adding some additional validation for each of the fields, each of the bits of data that you're accepting into the microservice. Well, you probably know where this story is going, that they actually responded and they said, well, we don't want to. We're not going to add any additional validation into our service. And we said, well, why not? Well, they responded and said, well, because the web application that I mentioned, that is the only client right now to our service. And because all of the validation is happening up front, right, well, we don't feel we need to implement redundant input validation for the service itself. And I will say, right, this should be obvious, but that is a horrible practice because there was a trust boundary being crossed from the web application to the backend microservice. The whole definition of having a service is that at some point, you're probably going to have or want to have multiple different clients calling that particular service. And so, right, to prepare for that, you want to make sure that you are validating your input appropriately. It is a basic practice, right, but an extremely important one. And so really, just to emphasize that application security practices like input validation, like code review, conducting your automated scans, looking for dependent vulnerable libraries, as we recently saw related to the Equifax hack and the Struts vulnerability, right? We want to make sure that these application security best practices, we've got those ticked and tied a lot better than we had before, because the focus of where the application might be vulnerable is shifting from the infrastructure, right, to the application itself. And so how do we figure out, how do we change our practices, update our practices with this changing technology environment? Now, this last slide in this section, this is just an example here. It turns out that AWS, Amazon Web Services, has a WAF, a Web Application Firewall. And as part of their WAF, the AWS Labs team has come up with what they call this Security Automations Architecture. If you just search for that, you can see the link down here on the bottom left hand of the slide. And it lets you, if you install this CloudFormation stack, it lets you create a number of different AWS WAF rules looking for bad things that we see here in the middle of the slide. Now, I'm not going to go through all of this here because this is just an example, but we were just talking about serverless computing, functions as a service. And so in this WAF implementation, AWS has gone on, and as you see it over to the right of the slide here, there are actually some Lambda functions. An AWS Lambda access handler, a log parser, an IP list parser. And this is an example of how we not only, one, have to understand modern technologies like microservices and serverless computing. Not only have we understand how to secure them, but also we could potentially utilize these technologies for our benefit, for a security-specific use case. If we take one example here, is scanning your application, scanning your website on a repeated basis, well, then this Lambda function over here on the right-hand side is going to pull on a regular basis the various logs from the S3 bucket up at the top right corner where it is actually stored and analyze those. And if it finds repeated bad behavior, repeated scanning, it's going to go ahead and update, right, the WAF to block those particular IP addresses. So good example here of using AWS Lambda for a security-specific benefit, a security-specific use case. All right, so let's move on to number 2. Seize the simple. How do we make secure DevOps? How do we make cloud application security effective in our organizations? And that is by making it simple. Leonardo da Vinci said, simplicity is the ultimate form of sophistication. Now, speaking of simple, let's go ahead and take a look at some code. I like to show some code every once in a while. And so the question here for the audience, right, as you think about this, as you look at this code, right, is to think in your head, well, what is the line of code or the lines of code that are actually vulnerable to this? Now, if you type into the chat window, which I don't believe I can see all of the chat responses right now, but go ahead and type into the chat window what line of code you think is vulnerable in this particular case. And I will give you a hint, right? It's actually vulnerable to cross-site scripting. Now, this is a very simple example here. As some of you are perhaps getting ready to type into the chat window, we'll go ahead and take a look at the, well, what is the answer? And here on line number 2, you can see that we are directly getting the look parameter, getting the parameter from the request on line number 2. And this is some JSP JavaScriptlet code inside of a JSP Java server page itself. So the source of the data is line number 2, this unvalidated, untrusted data. Because as you see from the middle block of this code, there's really no validation that happens here. And we are using that code, that value, excuse me, using the theme variable, using JSP syntax, less than % equal, to directly put the value of the data, the value of that theme variable directly into the JSP's output stream and sending it back down to the browser. So this is your classic case of reflected cross-site scripting. Right? So this is a very simple way, right? This is pretty simple in terms of finding this particular bug. Well, what if, remember earlier I mentioned single-page applications on that architecture diagram we had on the upper left-hand corner? It mentioned single-page applications. Well, what we in security now need to do is not only understand how a simple vulnerability bug like cross-site scripting works in basic code like we just saw on the previous slide, but we have to understand how it works in the modern development frameworks, like some single-page application frameworks that our development teams might be using. So we'll take AngularJS as an example here, but this is same thing applies to other frameworks like React and Ember and so on. And so we know that the best way to prevent cross-site scripting from occurring is to do output encoding. Make sure that we appropriately output escape, output encode the data that gets sent up to our server, and as we send it back down to the browser, we have to make sure to apply the appropriate output encoding. Well, now the good thing, though, is that if our development teams, our organization is using a framework, a tool, like AngularJS, it comes with built-in output encoding functionality, right? Using either the ngbind directive or the curly brace, right, variable expression, right? The output is automatically, right, output escaped, output encoded via this ng sanitize functionality. And so therefore helping to eliminate, right, prevent, mitigate a lot of the most common cross-site scripting vulnerabilities. Now, what about on the other hand, though? In certain cases, you might want to allow certain HTML tags to be used by your application. You might have like a social network. You might have a use case where you need to allow your users to put italics tags, bold tags, strong tags, modify the HTML of the data that they're typing in, right? To make it, they allow them to customize it a little bit. Well, in those cases, you want to make sure that the output is tokenized, but that certain HTML tags, like your less than, strong, closing, greater than, closing tag, right? That those tokens are passed through, well, a whitelist. Well, the good news is that Angular also has functionality using this ngbind HTML directive that allows you to do just that as well. So now the good news is we don't have to necessarily create a lot of this functionality, output encoding, escaping functionality from scratch. We can leverage what is built in to our frameworks that our teams are using already, right? How simple is that? Now, here's a couple examples of using both ngbind and using the Angular expression. We won't dwell too long on this slide since this is just an example. But there is another thing to consider. Now, not only is it really easy, right, is the best way to fix cross-site scripting, mitigate cross-site scripting is by doing the appropriate output encoding, output escaping. But there's also something else called Content Security Policy, CSP. Now, CSP is also a great way to prevent, mitigate cross-site scripting because it allows you to define a whitelist of known good sources of JavaScript and style sheets and other things. And by defining a known good source of that JavaScript, you help mitigate, you help prevent a lot of the most common cross-site scripting attacks. So content security policy is a great defense in-depth measure, right, when you couple it with the appropriate output encoding. But there's a catch, right? There's a catch that we know that if you turn on content security policy for your application, well, it prevents you, it blocks you from using inline JavaScript. Like if you're in your HTML, you've got some inline JavaScript in there, that won't work. That will break. Content security policy also prevents you as a developer from using certain JavaScript functions like eval and the function constructor that we see here in the second bullet. The problem, though, with content security policy, if you blindly turn that on for your application, and your application happens to be using AngularJS, because that's just what your development team decided to use, then out of the box, your application is going to break. That is because AngularJS uses features under the covers that are not allowed in standard content security policy rules, like eval and function. And they do this from a performance perspective. And so we want to make sure that if we are using content security policy, we've got to consider, well, what's the effect on our AngularJS applications? Now, the good news, though, is that the great developers that created Angular, they knew that this would be an issue. So all you have to do, if you want to use content security policy, is to utilize this ngCSP directive. Add this to the top of your HTML, and it's going to tell Angular not to use any features that break content security policy. Right? So how great is that? Now, would you say that this is all simple so far, right? This is in the vein of keeping it simple. We've got to, one, understand the vulnerability, understand what cross-site scripting is, understand what it looks like in code, understand how it affects and impacts our modern development frameworks like Angular and others. And I would say that that's all well and good, right? We've had a pretty good, as an industry, understanding of that, but we want to make it even easier. And that is where various static analysis tools come into play, because we want to make sure that we can automate, right? In the spirit of DevOps, automate the discovery and identification of a lot of these different issues, these vulnerabilities. Of course, from a free open source perspective, right, we've got Find Security Bugs, which is Java, Fan, which is PHP, PumaScan focused on .NET, Brakeman, Bandit, Flaw Finder from a C++ perspective, Quark from an Android perspective, and so on. Number of different commercial equivalents out there. But the way that we can make it even simpler, instead of just downloading, installing one of these tools, telling the development team to run them, pushing go on the scan itself, that could take anywhere from hours, right? Minutes to hours, which is a very long time in a DevOps CI/CD pipeline, continuous integration, continuous deployment pipeline. That is much too slow. So how do we make it even simpler for our friends over on the development team? Now, this is one example here on the next slide. This is a little screenshot from Microsoft Visual Studio. And inside of the Visual Studio, right, my friend and colleague, fellow SANS instructor, has installed an open source tool that he created, PumaScan, which was mentioned on the previous slide. And the way that we make this even easier for our dev teams, our DevOps teams, is that we want to provide immediate feedback here. So just like when you are typing in your Word document, when you make a grammar or a spelling mistake, it gives you a little underline, a little squiggly line. And as you can see here from line number 38, as the developer is typing some code here, it pops up with this warning, and it underlines the potentially vulnerable code. And it says, hey, we think that there is some unencoded data here. Unencoded data, giving you immediate feedback. Now, we don't lead with the vulnerability in this particular example, saying, warning, warning, there might be cross-site scripting here. We say, hey, you should probably encode this, which therefore then helps prevent the cross-site scripting vulnerability. So the way that we can be successful in modern DevOps environments is to make sure that we not only understand what we're doing overall from a security perspective, but we also want to try to provide tools similar to this that will give our development and DevOps teams immediate feedback, right? Moving at the speed of DevOps, moving at the speed that the business actually wants to move at. So that is trying to seize the simple there. And then finally, number 3, automate everything. We want to make sure that we can automate as much as possible instead of relying on a lot of the manual work that we might have been doing in the past. Now, here we've just got a brief mention of the CIS, Center for Internet Security Controls. These are formerly known as the SANS Top 20 Critical Security Controls. And listed here on the screen is, of course, the first 5, what CIS calls the first 5. And as we just glance at these are things that we have been working on and struggling with and trying to achieve for years in information security. Inventory, numbers 1 and 2, asset inventory of authorized and unauthorized devices and software. Now, I very rarely meet people that say they have an amazing, great, excellent asset inventory program in their organizations, because it's hard, it's difficult, it is challenging, especially in large enterprises with a lot of legacy infrastructure, to do a thorough asset inventory, asset analysis. Number 3, secure configurations for hardware and software. But then I really want to spend a little bit more time, in addition to asset inventory, talking about one of the hardest things to do is vulnerability, not only assessment, but vulnerability remediation. how do we actually drive our organizations to fix this slew of vulnerabilities that we are encountering? And all of these things are things that we have struggled in security, right, for years, for decades even, to accomplish these things in a scalable, automated, repeatable manner. Now, we've made inroads, but I would say that a lot of the things that are going on from a DevOps perspective, from a cloud security perspective, are helping us achieve a lot of those traditional security controls. If we take this example, infrastructure as code. In the not too distant past, and in many organizations still today, the traditional approach to standing up and deploying and delivering infrastructure was, well, you'd have some administrator, systems administrator, an admin that had various manual checklists and scripts, would make some changes to the particular system, and this caused configuration drift over time between various dev and staging and production and so on environments. But now today, what we want to do is we want to make sure that we treat infrastructure as code, not only the code that we saw up above in previous slides where it's our application code, but everything we do from an infrastructure and configuration management perspective, we want to treat that as system engineering as well. Now, there are a number of popular configuration management tools that we see down here at the bottom. A number of you are probably using some of these tools in your environments, tools like Chef, Puppet, Ansible, SaltStack, and so on. Well, if you are in the cloud, and on the next slide here, we've got an example, right? AWS's version of this is, of course, CloudFormation, where you can, just via, in this particular case, YAML, or with JSON, go ahead and define what your infrastructure, what your environment should actually look like. So now you don't necessarily have to have all of those manual scripts that people might have used to create stand-up infrastructure in the past, but now you can define what type of instance you want in here, what groups, what security groups this is a part of, what subnets this should be a part of, and so on. And so now, using code, using infrastructure as code, you can stand up, right, your environment. And to do this, right, in an automated way. And once you've stood up your various EC2 instances, well now, right, in the cloud and as part of your DevOps workflows, you now have an easier way, much easier way to do inventory. Using a command like we see here, AWS EC2, describing your instances. Here we are using the JQ, right, command, JSON query, to go ahead and parse the resulting JSON and get the corresponding output. And so now we've got a way to do asset inventory in much more automated, much more efficient way than we had perhaps done in the past. Now, the last thing that I want to mention in the presentation is one of the things that is a challenge for us is driving remediation, actually fixing the vulnerabilities that we encounter. I have been a part of and worked at organizations and seen organizations where it takes weeks to actually deploy a fix for a simple bug like cross-site scripting or SQL injection to production, because a lot of the deployment process was actually manual. And there was a lot of management processes like going through different test environments, getting QA testing, feedback, getting management review of all of these things that really delayed pushing changes out to production. And so now, right, that brings us to this concept of blue-green deployments. This is not a new concept. The concept has been around for a very long period of time. The idea being that you've got your production environment. Let's just call it the blue environment. The names of the colors could be anything. It could be red, black, purple, orange, whatever you want it to be. Right? But the standard industry term is to call it a blue-green. Blue-green conceptually is you've got the blue production environment. And you want to deploy some changes. Instead of deploying it, of course, into the production environment directly, you'll have a separate identical infrastructure called your green environment. And you deploy your fix to cross-site scripting, your fix to SQL injection to that green environment. And by doing so, right, you can test in that green environment first. So you've got an improved ability to roll back if there's some change, something that goes wrong with your change. And you can more quickly deploy to production because you can now switch from that blue environment to the green environment whenever you need to, once you've tested those particular changes. And the reason that this hasn't been perhaps as widely utilized across a number of enterprises, across various companies, is because it required you to have two identical sets of infrastructure. Well, now, with the cloud, where it is much easier to stand up identical sets of infrastructure using, right, things like CloudFormation that we just saw on the previous slide, You can therefore stand this up much more effectively and have a separate green environment that enables you to do faster testing and faster remediation of your security vulnerabilities. Depending on the cloud provider and depending even within AWS how your architecture is set up, there are a number of ways that this can potentially be done. Let's go ahead and in this webcast, we're going to talk about just one example. If you happen to be using Docker containers and you're using Amazon's ECS, the EC2 container service, to manage those containers for you, this is how it might look from a high-level blue-green deployment perspective. On the left-hand side, towards the bottom here, you might have your blue ECS service, your EC2 container service, defined in AWS with a specific service description and a specific task description describing what containers get deployed onto your container instances. And the blue ones, of course, are the version of your application that is running in production. Correspondingly, on the right-hand side here, in the lower right-hand corner, you would create a new separate green service and corresponding task definition. And once you stand that up, well, and that contains your updated code, your fixed code, the one without vulnerabilities any longer. And so once you've tested that out, you can go ahead and map, right, the new green service to up at the top. That's your elastic load balancer. So then you can slowly start to scale up your green service by increasing the number of tasks. And when you've sufficiently satisfied that your green service is performing effectively, that your code change actually works, you can then set the number of tasks for your old, vulnerable, blue service down to 0, right? Letting you do this blue-green deployment in the cloud, leading to more effective, again, remediation. From a command perspective, right, this is what it looks like. If you've got you want to deploy, create the new green service here, and in the middle of this top line of the command, we've got this green web ECS service.yaml. That's just another cloud formation template that you can use to stand up that green ECS service. Then these last two commands here are, of course, increasing the count for the green service itself, and then turning off at the bottom the blue service whenever you're ready, setting that to 0 in the lower right-hand corner. And so this is just an example of how you might do this, right, in your modern DevOps and modern cloud deployment environment. So all of this is about how do we figure out how to get to yes with our organizations. And really, I really love this tweet. If security introduces blocking to the organization, and many of us have probably experienced this before, it will be ignored and not embraced. And so what we've got to figure out how to do is, as we step back, right, from all of the implementation details, we've got to figure out, well, how do we champion change for our organizations? How do we work with the modern technologies that our DevOps, right, teams are doing, that cloud is introducing, to champion change, not only in terms of introducing security into those environments, but how do we utilize some of these technologies ourselves from the security side? How do we, too, seize the simple? How do we make it simple, not just throwing a scanner or scanner results over the wall to our development teams or DevOps teams, but how do we integrate even further left into the workflow, making it easier, providing that immediate feedback? And then finally, number 3, how do we automate everything in terms of driving more automation, right? Which is really at the heart of what DevOps is actually about. And we saw a few examples of each of these things. If you have any questions on any of these items, feel free to contact me. My contact information is up here on the slide. The material from a lot of the material from this presentation in particular is taken from the new SANS DEV540 Secure DevOps and Cloud Application Security course that I mentioned. And as I mentioned at the beginning, this is just the first in a 5-part webcast series about DevOps and cloud application security. And so I'm going to go ahead and pause and open it up for questions. I'm going to turn it over to Carol here in a moment to share any questions that you all might have. But just wanted to highlight that the new Dev540 course is running in the coming months here, next month in December in Washington, D.C., in New Orleans in January, in San Diego in February. I'll also be in Amsterdam if any of you are across the pond and want to take that in Europe. We've got a number of runs scheduled throughout the year, so hopefully we will see you at one of these events. And I want to go ahead and turn it back over to Carol to open it up for any questions.
All right, thanks for that great presentation, Frank. While we give people a moment to see if they have any questions to submit, I will let everyone know that you can find your CEUs for all completed webcasts by logging into your SANS portal account. Navigate to your account dashboard, then click My Webcasts. You can then download your CEU on the right-hand side of the web page. And then, as I've sent in the chat window, a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. Well, Frank, I don't see anything submitted at, oh, here we go. Is the Dev540 course more for technical audiences or managerial?
Yes, the Dev540 course is definitely for technical audiences. We have run it, when we ran it last month, there was a mixture because we are finding a number of managers are interested in this topic and they want to get a better understanding of what their technical teams are doing. So, it is appropriate for managers, but it is a hands-on technical course. We have a virtual machine, like perhaps many other SANS courses that you're familiar with have, where we have a whole DevOps CI/CD pipeline running on the VM itself. And so we are using tools to inject security at various points in terms of static analysis, scanning directly into that pipeline, right, using Jenkins, using Docker containers. And then as we move on, right, to day number 3 of the course, which talks more about cloud application security, specifically in AWS, we are migrating that pipeline to run in the cloud, utilizing various AWS services. And so yes, it is definitely a hands-on technical course. You should have some familiarity with Linux. You should have some familiarity with web application security and application security issues, and have some conceptual familiarity about of working in the cloud as well. So yeah, definitely a hands-on technical course.
All right. Well, I don't see any more questions. Do you have any closing thoughts or?
No, I just want to thank everybody for attending. I feel like I say this all of the time, but I really feel like DevOps and cloud are the future of the way that organizations are going to be developing and deploying and managing software. And because it's the future of development, it's also the future of IT, and therefore it's the future of information security, because we need to understand how to most effectively work in this environment, in this new DevOps and cloud world. How do we secure those technologies, and then how do we also utilize them for our benefit? So thank you all very much for attending.
All right. Well, thank you so much, Frank, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.